What is robot arm configuration in kinematics? Imagine trying to tell someone exactly how a robot arm is positioned just by looking at its joints. That's what robot arm configuration is all about. It's a way to describe the position of every joint in a robotic arm at a specific moment. Think of it like a set of instructions that tell the robot how to hold itself. In robotics engineering and development, these instructions are usually written as a list of numbers called joint variables. For a robotic arm with rotating joints, these numbers are angles. For sliding joints, they are distances. This list of numbers is called the joint space configuration. Each unique set of these numbers shows a different pose or shape of the robot. Knowing the robot's configuration is key because it links what's happening inside the joints to where the end of the arm is in space. This connection is made through what are called kinematic equations. These equations help us figure out where the end-effector, which is the tool or hand at the tip of the arm, is located and how it's oriented. There are two main types of these equations. Forward kinematics takes the joint variables and calculates the exact position and orientation of the end-effector. It's like plugging in numbers and getting a precise location. Inverse kinematics does the opposite. It starts with a desired position and orientation and then finds the joint variables needed to reach that point. This process can be tricky because sometimes multiple joint configurations can reach the same spot, or no solution might exist at all. The set of all possible joint configurations makes up what's called the configuration space. The size of this space depends on how many joints the robot has. For example, a robot with 6 joints has 6 joint variables, so its configuration space has 6 dimensions. The design of the robot, including the types of joints and how they are arranged, influences this space. It determines how far the robot can reach and what positions it can achieve. In real-world robotics, understanding and controlling the robot's configuration is essential. It helps in planning movements, avoiding collisions, and making sure the robot performs tasks accurately. Robot controllers use configuration data to plan smooth, precise paths. Simulation tools also relying on this data to visualize how the robot will move before it actually does. In simple terms, robot arm configuration is the set of numbers that fully describes how a robot is positioned at any given moment. It acts as a bridge between what's happening inside the joints and what's happening outside in space. This understanding allows engineers to control robots more effectively, making sure they move correctly and do their jobs well.